Hello internet, hello you. My name's Susan and today we're gonna pretend that it's my birthday. Why and how, I'll explain in a minute, but first let's get ready. When I was younger, both my grandma and my dad would gift us that they would cook whatever we want. From my grandma, or how I call her, Oma, I would ask for a risotto, and for my dad, I would ask him for English breakfast. So yeah, today I want to talk about two topics that aren't perceived in the most positive light online. English food and math. But first, let's watch some of our stuff. Well, because yes, I do love English breakfast and I do love math. And I know these are probably not the two most popular sentences online, but I don't really care. And don't get me wrong, I don't speak of English food in general because I don't really know what's there besides fish and chips and English breakfast. Normally, I think it would include some egg, bacon, and a hamburger, but since I don't really like eggs and I don't eat meat, we're gonna replace them. Instead of bacon and a hamburger, I'm gonna use seitan, and I'm gonna use two different kinds of tofu to replace the egg. And this is actually what we're gonna start with. For the tofu-based scrambled egg alternative, we're gonna use an onion and some garlic. Half of the onion should be enough, so the other half goes back into the fridge. So the explanation why I love British breakfast is because it reminds me of my dad and my childhood. But then, why do I want to talk about math? Well, you see, I've fallen enough in love with math to study it. And I actually think it's quite sad that the only times I hear girl and math on the internet in one sentence is in girl math. And now, I personally don't agree with girl math, but that is a completely different topic. And believe me, I've heard enough complaints from especially girls about math. People love to ask, what do I need this for? Why do I have to learn this? I'm never going to use this later on. Now, I once saw someone on the internet say that their math teacher referred to math as a workout for the brain. And I don't want to disagree with that. I just want to add stuff. Because math is not just numbers or looking for x. Math as a whole is so much more complex and can be so beautiful. I feel if people put their prejudice aside, everyone would find a side in math that they like. And a lot of times you use mathematical concepts in your day-to-day life without even realizing. Physics, for example, often uses coordinate change. And if you've ever played chess or used geographical coordinates, you're already familiar with the concept. Because on this board, for example, if I want to tell you where what is, it would be the easiest to say, okay, we start here in our origin. So this is our point 0, 0, and we call this the x-axis and this the y-axis. And then I tell you, okay, 1, 2, 3, 4 units on the x-axis and 1, 2 units on the y-axis, and then on the meeting point, we're there. However, let's say I've put my ingredients from the board into the pan, and I now want to describe where in the pan my ingredients are. Now, I could still use the same coordinates, saying, okay, my origin is in this point, and I give you the x-axis and y-axis units. However, this is a bit complicated because my board on the x-axis is a bit longer than my pan, so I can't use the entire range in the x-axis. However, my pan is a bit longer than the y-axis, so I would maybe go into negative space or whatever. And especially the corners, it's gonna get complicated quite quickly. So what do we do instead? So instead, let's say we put the origin into the middle of the pan, and instead of a x and y-axis, we use the radius and the angle. We could, for example, say that the line that connects the origin or the 0 point from the middle of the pan to the handle, on this line, this is the 0. So if I want to tell you that something is down here, I would tell you the difference between the point and the origin, and I would tell you the angle between the axis that connects the origin and the handle and the point where I'm at. As long as we stay in one system, this change of coordinates makes everything easier. Okay, but Susan, what do I do if I want to transfer from one system to another. Isn't that more complicated? Wouldn't it be easier to just stick to one system? We do have a formula that helps us transfer from one system into the other. And I promise these transformations aren't too complicated. And once we did our calculations in our preferred coordinate system, it's also pretty easy to transform back into our original system. Once you know how to transform from one coordinate system into another, it's not too hard to transform into other coordinate systems, as for example a sphere or a cylinder. What you need to look for is some clever units, for example height, width and length. And a cylinder is basically a combination of a box and a pan. Just like the tofu, the can has a height. However, width and length don't really make sense. On the other hand, the top of the can is just a smaller version of a pan. So we can again take an origin, say this is our 0 point, and from here measure the angle. To a mix of tofu, I'm going to add some Tabasco, some tomato paste, some chili garlic paste, and a tiny bit of mustard. So then what about the tomato? Because from above in 2D it might resemble a can, but it really isn't. Again, we're going to work with angles. We pretend that our origin is in the middle of the tomato, and we can go with one angle from the top to the bottom. So this angle describes half of the circle, while the other angle stays on the equator, and this one can go all around the tomato. Since in this system we're just using 2 units to describe our point, we say it's 2-dimensional. Our coordinates in the pan or on the board are also 2-dimensional. Our can or box of tofu, on the other hand, have 3 units, so these are 3-dimensional. Now that the tofu has gotten some roasty aroma, it's time for some milk. Just as with the can or the pan, we're going to use the radius to make a 3-dimensional object out of a 2-dimensional object. Using just the 2 angles, we can describe every point on the outer part of the tomato. So in order to be able to describe the inner parts as well, we're going to use the radius. And again, the radius is going to describe the distance between the central point of our tomato to the point where we're going to go. And I think it's self-explanatory that we always use the coordinate system that works best for our object. So if I want to tell you to put the tomato into the center of the pan, I'm not going to use Cartesian coordinates, the board's coordinates. For some more flavors in the tofu scrambled egg, I'm going to use some cayenne pepper, some paprika powder, some petersilia, and finally some powdered garlic. And the best thing is, when transforming coordinate system, you're not bound to angles and radius. As long as it's evident, you can use whatever. I'd say chess is a prominent example. The players use, instead of a y and x axis, an axis with letters from A to G, and one with numbers from 1 to 8. But you might as well use color gradients. Mathematicians, of course, have distinguished names for these units. So I've already mentioned the radius, but then we have latitude and longitude. And in spherical coordinates, so round stuff, we have the radial distance, the accipuntal angle that goes round and round, and the polar angle that goes up and down. Also, coordinate transformation doesn't discriminate. You can transform from any form and shape to any other. And of course, the difficulty between transformations might vary, and some are easier than others. However, the system and the techniques stay the same. And once you've got the hang of it, it can become a powerful tool. Because trajectories that are super complicated in one system might be super easy in another. Now I think for a completely real English breakfast, I would have to put my toast into the pan, but I'm not going to do that. I'm sorry. We have the toaster for a reason. So if you're a girl and you're watching this, please don't let anybody ever tell you that you can't do math. Or worse, that you don't need it. Because math is not defined by numbers and x. Because if you know where to look for it, you'll find math in your everyday life. And I promise you, you already use a lot of math in your day-to-day life without even realizing it. I want to start a series where I show you some corners of math that I think are beautiful and not taught in school. Because I believe that once you lose your initial skepticism, you might realize that it's really not that bad. And if you stop looking at math like it's personally offended you, you might realize it might come in handy. Especially with statistics. It is super easy to lie with statistics. So please stop hating math and give it a chance. I don't even want to disagree that math that we're taught in school often sucks. But that is only the surface and barely even real math. There's way more to it, and if you're open to it, who knows, maybe you'll even discover a part that you like. So please do me a favor and don't hate on math just because you don't like long division. In my eyes, that's a bit like saying you dislike music because you were forced to learn the flute. Also, just like you can manifest positive things, you can also manifest negative things. And if you heard it or told yourself often enough that you can't do math, well then, in the end, you and your brain will believe it. And that leaves you vulnerable for people to know how to use math to manipulate you. So, how about you come with me and we try out some new things? So yeah, I'd like to make this a series, and instead of talking about girl math, I talk about math for girls. If you're still here, you made it to the end of the video. Thank you so much, and I hope to welcome you again in my kitchen.